Alright, so I've completed this work, and the file right now you could say isn't really that heavy. It's about a standard size of the projects that you'll be working with. But try to assume that you'll be working on a project like this on a much larger scale for a big company in about 15 or 20,000 meters and up. Now, the bigger the project is, the longer it takes to place the elements, and a simple process such as this might take you 2 or 3 days in a big project, or even at least 1 hour in a simple one. But either way, make sure to do this step, because it will prevent any redoings or changes later on. But now we're going to go through a process of deleting whatever I've placed here together using an excellent method. So select this and delete it. Now we're going to do this process using the Dynamo instead. We're going to see how much the Dynamo helps us to speed up the process of deleting these spots and placing the Dynamo in the exact points that we wanted. And because we have the AutoCAD file, this method can really be beneficial to us. Now, in order to use this method, although later on as a whole in the modeling videos, we'll be discussing the effects of Dynamo in full detail, and we'll give you some examples to see in full extent how much this can speed up your process. And generally, when we're working in the BIM field, we have to be knowledgeable enough in modeling to do the work properly and quickly, so that we'll be able to better analyze, process, and rework the issues in the project. So we'll spend more time on the efficiency of our work rather than the modeling process itself. So now we want to go through the steps of the method using Dynamo. As you can see, I've isolated this file and I've placed the points exactly where I've mentioned before. Now, these are usually in the form of blocks or circles. If they are circles, we can just assign the center point, but if they're in the form of blocks, it's even better. So I'll just double click on this, and you can see the name of the block is fire, so then I'll press OK. Then we'll be redirected to the edit family. Because we don't know where the 0 point is located, we'll need to use the palette over here. Now it's either open itself, or you'll have to press this button here to open up the tool palette, where you can go over to the parameters section. Here we'll use the base point tool and select the center of this circle. Then we'll hit close and save. Now, because the block that we had over here wasn't set on the 0 base point, the file has been moved to over here because the coordinations have been changed. Now we can select this and using the move tool, grab from this point here, then place it over here and insert it on the exact point where it should be located. It's all based on the plan over here. Then I'll hit Ctrl S to save it. Now I can go over to the Insert tab and select the Extract Data tool. Click Next on this, and then we'll go over to the directory that we need to. For example, I'll go to the Beam course and then here open up the Files folder, and then finally save the file under the Dynamo folder, and I'll name the file itself Fire Points, and then I'll hit Save. Then here I'll hit next on this window. Now a table is presented here of the objects and items used, but we don't need all of them, so I'll uncheck all of the objects. I'll find the fire object and activate its box. Then I'll hit next. Then over here I'll uncheck all of the items again under the category bar and only keep the geometry. Then under the geometry category itself, I'll uncheck the scales that we have and only keep the positions X, Y, and Z. Alright, after that I'll hit next. And then over here we can see we have the chords, the name, positions of X, Y, and Z. Now what I can do to clear this out is uncheck the show chord column box as such, and then we can get this as light as possible. And then I'll hit next and check the output box here, and then I'll give a destination to it to store the external file. So I'll open up the path to where I'm saving the families, and I'll put in for your access as well, right here in the Dynamo folder under the XLA type. And finally finish here. Now let's go to the path where I've saved the file. So I'll open it up over here in the background, open up the MEP and then the Dynamo folders and the Excel file. Now you can see the columns here, name, X, Y, and Z. And the name isn't really useful to us either because it's repetitive, so I'll select it and delete it using this icon up here. So just keep the X, Y, and Z. Then save the file using this option and then save as, where I'll save it in the same folder, and I can change the type as well to workbook and then hit save. After that, I'll open up the Dynamo. First, I'll have to save the path of this and then minimize this, and then go over here in the Revit file under the Manage tab and click on the Dynamo tool. Now I'll create a new file here and put it on manual settings. Then I'll go up here to the search bar and search for file path. Now I'll specify the file path that we have for the Excel file in the Browse tab. Then I'll look for File from Path. Now we can do this using a right click and searching in the search bar. Let me just pull this over here and minimize this, and then we can look for File from Path. Alright, now this turns the path to the object. I'll connect it and then hit run, and alright. Now I'll look for import Excel, then I'll connect it to the thread. Now we'll have to select the name that we have for this file, which is summary, and hit Ctrl C to copy it. Then I'll go over here on the Dynamo and look for string. I'll paste summary inside of the string, then connect it to the sheet name from the Import Excel tab. Then if I hit run, Excel file through the list. Up here where we have the XYZ for the name, we can use a list tool. Search for list.deconstruct and then connect it to the data. Then hit run, and this basically separates them. Now I don't need the first, but I'll need the result. So I'll look for get item at index. I'll connect this to the result and then hit Ctrl C and Ctrl V twice to get two more of this. Now these signify the X, Y, and Z. Then right click and align it to left, then set them using Ctrl L. Now I can right click here and look for transpose to open up the app. From one side I'll connect it to the deconstruct and to the get item at index from the right. We just have to make sure to connect it to all three and then we can hit run. Now the XYZ that we had from the list are inserted inside of the 0, 1, and 2 indexes. Now I'll create a code block and type in 0, 1, and 2 with semicolons between them. 0 is X, 1 is Y, and 2 is Z. So after connecting them, we can hit run. After this, we can get to the next step. Now here we can right click and look for to number, which turns our string formation to numbers. So we connect it to the list here, but we just have to make sure to make 3 of them, 1 for each. So connect this one to here and then this one and this one as well. Then I'll hit run. After that, I'll search for translate XYZ geometry and I'll open the app and just leave it be here for now. After that, we'll have to search for points XYZ. This opens up the app point by coordinates and we can connect it to the thread from the entry side. After that, I'll hit run once again to get the points down here. Now you can see how exactly they've been placed where they need to be. Now the Z is set on 0 and we need to move it higher. Connect the geometry to the point and then look for number slider. Now this is an interesting app. We can put in 2.1 for the minimum elevation and 2.7 for maximum. and each step is going to be 0.01. Now I can put this on automatic settings and then hide the point by coordinates app. Now later on in our project, if we need to move the suspended setting for any reason, we can do it way smarter using this method. This moves all of the points to the exact height that we want at the same time. So I'll leave it be on 2.1 for now, and then I'll go over here and look for by points and open up this app, the family instance. So we can connect the point to the geometry this way. Then I'll look for family types and I'll open up this app, and then we'll just have to look through the family types list to find the fire family. So it's this one, the fire protection sprinkler wet, which we can connect to the family instance like this. Alright, and now just some more stuff to do. Let me just minimize the dynamo and put it on manual settings for now. Then we can take a look in the 3D view to see what we have here. And we need to find where this part is actually placed inside of the plan. And we actually have an issue here. Because the coding for this is minus, we need to put in minus for the height in the dynamo as well. Right now it's located in plus 2.1. We'll just have to wait for this to load up and see what we have here. Alright, now let's rotate this and then we can zoom out to see this part in full detail. And let's also put the dynamo on manual settings. So here is where we have the number slider, and we need to make sure to match this with the correct coordinates that we have in the plan. So first we have the minimum, which we can put on minus 2.1. There we go. Now we can also change these settings by grabbing this and scrolling through the heights. Now you can see the changes being made in the plan on the right as well. So right here you can see where it's exactly located in the center of the plan, and it can help us really speed up the process. Now we can go through the 3D view and see where exactly this part is located and assess it. Now the height wasn't exact before, so we can pull it up, and we can also create a cut line here and analyze this part thoroughly so we can put it in the exact point that it needs to be height-wise. Meaning I can go over to the annotate tab and select the spot elevation option. So select this, and then let's see where we can go in the plan to use it. So you can click on the spot elevation that we have here on the left, and it says target, and instead of that we can put it on no symbol settings. Then we have the relative base, which is based on current level now, but we can put it relative to level minus 2.1. Alright, then we can go back to the dynamo itself and put in minus 2.1 on the number slider. Alright, then after that we go back to the Revit file and we can select this point that we have in the plan, and then let's take a look at it in the 3D view to see where this part is inserted. Now what would happen if we bring up the minus 2.1? Let's go back to the cut that we created here to see. So select this cut and double click on it to go to view, and we can see the elevation points here on the right. So first we have 0.1 and then we have 1 meter above it. Now I'll create a reference plane over here that goes through here, and then I'll use the pick line and put the offset on 1/10 lower so we can get our 0 point. Alright, and then we open up the visibility graphics menu to see if this is hidden or not. Alright, hit OK to close this. So I drew this just a bit bigger just so we can analyze it better and get the exact changes needed. Alright, so up to this point we can put it 0.1 for this, and then let's see what we have here on the right. So select this and put in 1 meter. We actually didn't need to draw the plan because we already had the 00 points here. So I'll go over to the Annotate tab and I'll select the measure tool, and from this point start the measurement and then go over here. Let's see where our suspended ceiling is, because that's what we need to measure this according to. Alright, so as you can see, we have the suspended ceiling located on the 00 level itself at the exact point. It's just about 5 centimeters higher. So I'll put in 0.05 and the number slider. And alright, if we go back to the 3D view and rotate this, we can see where this point is located, and it's exactly where we need it in the 0 point. It just comes out a bit just so we can see it better. So this is a method that you can use in the Dynamo, and I'll make sure to save the file and put it to your access as well. I'll make sure to save it over here in the Dynamo folder, and I'll name the file itself the auto place sprinkler by points. There we go, and then we can hit save to finish it up. Then we can close the Dynamo and get back to the Revit file. Now for the later levels as well, for example, you may need to use this method in the Dynamo again. You can first extract the Excel file for the higher levels in the AutoCAD file itself, and because we've already written the program, you just need to hit run. Then you can easily run the process and speed up your progress. Now this method can also be used with furniture as well, but because in our projects we have different types of furniture such as sinks and so on, you need to get different outlets for each of them if you're working based on furniture. So that's why you may not be able to maneuver as much with furniture as opposed to tools like